Hi guys, here we are again doing some limits, and today we're doing limits involving trig functions. So here is the basics that you're going to end up memorizing after you do a couple of these questions. So the main thing is we're going to try to get every single one of our situations here, our examples, to end up being, the limit as x approaches 0 of sine of x over x, because I know when I get there, that will give me 1. And I could record another video proving a couple of them why this is true, but I don't see it happening when you get to college. Hey, prove this and prove that. It's just a well-known, and you're going to be given a chart over this. So you can either write it down or just memorize it. So here we go. Our first example, I have to find the limit as x approaches 0 of sine of 5x over x. So it'll be nice if I can make this, the same thing right there. So if I could have 5x right here in the denominator, I will be able to use this right here. So if I just simply multiply by 5, and I multiply by 5 over 5 because theoretically I'm multiplying it by 1. And then I'll just split that up. So I'll put 5 right there. And then that gives me sine of 5x over 5x. And then I have this 5 right here in the numerator left over. So times 5. And then since we're using this to our advantage, we're going to just say, hey, I'm going to label y 5x. So instead of writing 5x, I'm just going to rewrite it as y. So at this point, I will find the limit as y approaches 0 of sine of y over y. And then, yes, I have this 5 right there. And I'm also finding the limit as x approaches 0 of 5. So at this point, I know that I can use this to my advantage because this equals 1. So if this equals 1, and I know when I'm trying to find the limit of a constant, that is equal to the constant. So 1 times 5 is 5. And after you do a couple of these, you're going to be able to do all that in your head without writing it all out. But it's likely your college professor will want the work, or at least some work leading you to the right answer, just not simply 5. Okay, so now this one, I need to make the denominator equal 2x, not just 5x. So I can again multiply by 2 over 2, and then I will call y equals 2x. So I have the limit. I will put the 2 right there like we did in example 1. Okay, so I will call the limit as x approaches 0 of sine of 2x over 2x. So I move this 2 over to this side to pair up with the x, and then the 5, I'll have to put 5 over off to the side because it's not helping me at all. So, and then this is working out for me, and then I have the limit as x approaches 0 of, I have this 2, and then I have this 5. If you want to circle that so you don't lose track, you can do that too. So this 2 is this 2, this 5 went right there. Okay, and then at this point I know I can just find the limit as y approaches 0 of sine of y over y, because I'm substituting 2x for y. And I know this equals 1, so there's that. And then at this point, I'm just trying to find the limit of the constant, which that equals the constant. So good for me. So if this equals 1, this equals the constant. So the limit of all this thing, that is just 2 over 5. Okay? So I know it's getting better. Now, of course, the next one we have, it's not that pretty. but it's okay. We're still going to use the same strategy that we've been using. So I know if I have sine of x over x, that gives me 1. And also, if I have x over sine of x, that also gives me 1. Okay? I will erase that because it's in my way. You're welcome to add that to the front page. You're welcome to add that to whatever place you want. Okay, so let's think about this. I need 7x in the denominator. So I'll multiply by 7. That will take care of the 7. I will have to multiply it by x, because that will give me 7x in the denominator. But then I need 3x in the numerator. So I will multiply that by 3. I'm color coding it so I don't lose track of what I'm multiplying, where it goes where, what goes where. Okay, so I have the limit as x approaches 0 of sine of 7x. That's what I have. And I also have the limit as x approaches something over sine of 3x, because I'm just splitting that up. Okay? Now, I need 7x in the denominator right here. And I have 7x right here. I have this 7 in red, and I have this x in green. So I have this 7 and this x. Okay? Now, right here, I need 3x in the numerator. I have 3 and I have x. So I'm using this one and this one. And then what do I have left? I have this 7 and this 3. So the limit as x approaches 0 of this 7 over this 3. Okay? That will account for everybody. So 7 in the numerator, 7 in the denominator, 7 in the numerator. I mean, not x, you know what I'm saying. X right there, 3 right there, and 3 in the denominator. Okay, now that's beautiful because I can just call y equals 7x and I can call z equals 3x. Or you can just use any letter. It doesn't matter. Okay, so I have the limit as y approaches 0, sine of y over y. I know that equals 1 because that was the whole goal. That's why we did this whole crazy thing right here. Times the limit as z approaches 0 of z over sine of z. And that I also know equals 1. And here I'm trying to find the limit of a constant. And that is the constant. So 7 over 3. Okay, multiply by 1, voila, 7 over 3. Okay, as you keep on working on it, you will be able to find shortcuts, but this is what you need to do to prove or to show your work. Now, tangent of 4x over 3x. I know from over here, if I get tangent of x over x, that will give me 1. And you'll never believe what we're going to do. That's right, we're going to multiply by 4 because I need to have a 4x in the denominator right there. So this 4 is going to go there and then the 3 is going to get out of my way. So I have the limit as x approaches 0 of tangent of 4x over 4x, and then I have the limit as x approaches 0 of, what do I have left? I have this 4 right here left over, and then I have this 3 left over right here. And at this point, you already know this equals 1, and then the limit of the constant is the constant. 1 times the constant, voila, 4 over 3. See, we're picking up the pace. It gets better. Now, this one, I have this crazy thing right here. Don't let this cute little thing scare you, okay? So from here, I know if I have 1 minus cosine of x over x, that equals 0. 1 minus cosine of x over x, that equals 0. So I'll just go ahead and split that up, make that a product. How do I do that? Well, I have the limit as x approaches 0 of 7 times the limit as x approaches 0 of 1 minus cosine of x over x. Okay? The limit of a constant is the constant, so 7. The limit of this, I ripped my paper, it is 0. You're like, 0 is not good. Yeah, it depends. 7 times 0, that's 0. Last one. So for the last one, we have, I'll just show you the short answer and then I'll show you the long answer, the long work, why that is true. As you keep on working on this, you're going to be able to find your own shortcut. Yeah. Okay, so when you see sine squared of 2x over sine squared of 9x, you're like, okay, squared that, I get 4, squared that, I get 81. Is that the right answer? Yes. But why? So I'm trying to find the limit as x approaches 0 of sine squared. So what does that really mean? Sine squared means sine times sine. Yes? Yes. So I have sine of 2x times sine of 2x. Sine squared, yes? Oh. And then over, same idea, sine of 9x times sine of 9x. Okay? Now we're going to split that up and make it work like we did in example 3. And you know everything is limit. So I have the limit as x approaches 0 of sine of 2x. I have limit of x approaches 0 of sine of 2x. And then I have the limit as x approaches 0 of something over sine of 9x, and also the limit as x approaches 0 of sine of 2x. 1 over or something over this. Okay? I need 2x right here, 2x right here, 9x right there, 9x right there. So I have to multiply. Okay, I will use green for 2x. So I need 2 right here, and I need 2 right here. Okay, that gives me, I have to put a 2 and a 2 on top because I need to multiply like by 2, you can see, by 2 over 2 because that equals 1. So if I have a 2 right here and a 2 right here, I have to do a 2 right there on top and 2 right there on top. It doesn't matter where you put it, you know, just it's going to be there. And then I need x. X right here, x right here. I could put x right there, but why would I put there? Because I know I'm going to need 9x right there. So I can make that equals 1. So I'll put x right here, x right here. This from this from that. Okay, looking good. Now I will use red because I need 9x right there on top. I have the x, I need the 9. I need 9 right there, 9 right there, another 9 right there, another 9 right here. So this 2 with this 2, this 2 with this 2, x we already did, so and then the 9 and 9. I know all of these equal 1 because that was the whole goal, that was the whole point. That leaves me with 2 times 2, and then 9 times 9, leading to 4 over 81. This is why this is the short way, and this is the reason why this works. These are all the examples I have for you today. Goodbye.